So you have your combinations formula. This is, if you remember, selecting objects where the order doesn't matter. Like if you were getting a poker hand and you were choosing 5 cards of 52, it doesn't matter the order you get those 5, and you're just trying to count how many ways that that can be done. So with the first one, 5, choose 3, if you go to the formula, one thing you notice with the formula, and I'm going to put the formula up for each of them, is when you have 5, choose 3, you're going to have a 5 factorial on the top, a 3 factorial on the bottom, and the other number adds up to the 5. So for 10, choose 2, you're going to have a 10 and a 2, and the other number adds up to 10. 10, choose 8 will be 10 factorial over 8 factorial, and the other number on the bottom is 2 factorial. Here we have 7, choose 0 factorial, so that would have a 7 factorial on the top, 0 factorial on the bottom, and another 7 factorial on the bottom. And then 100, choose 98. The other number on the bottom would be 2 factorial because it has to add up to 100. Now, factorial means you multiply all the way down from that number all the way down to 1. So if we start expanding, you'd have 5 factorial, 4 factorial, and once you get to 3 factorial, you can stop because that can cancel out with the 3 factorial on the bottom. So we are just left with 5 times 4, which is 20, divided by 2, which is 10. Same thing on the next one. You go 10, 9, 8 factorial, because that would cancel out with that 8 factorial on the bottom. And then you just have 10 times 9, which is 90, divided by 2 factorial. And 2 factorial is just 2 times 1, so it's just equal to 2. And that'll give you 45. Notice that the next one is identical, because choosing 2 items from 10 always leaves you with a group of 8 left behind. So choosing a group of 2 is the same as choosing a group of 8. 7, choose 0. Well, 0 factorial by definition is equal to 1, and the 7 factorials will cancel out. And this one is basically, you can even think of it, you have 7 items, you choose none of them. How many ways can you do that? 1 way, you don't choose any of them. And finally expanding that last one till 98 factorial, then dividing. This will be 9900 divided by 2, 4950. So we have an application to the binomial theorem. And this is how the binomial theorem is on your formula sheet this year. Last year, you had this formula. And this part in green, n choose k, a to the n minus k, b to the k, is exactly the same as this part right here. Instead of k, they use r. But other than that, it's identical. And instead of the choose notation that we had last year, this year we have the n over r. So the other thing that's not in our formula this year is the fact that that is term, it won't be k plus 1. Now it'll be term r plus 1. Now they don't tell you it's term r plus 1 because they want you to see a pattern. Here's term 1, here's term 2. They don't give you much to see the pattern. But can you see that when you have term 2, that the number underneath is 1 less? So when you have term r plus 1, the number underneath here is 1 less, which we had in our old formula as well. So if we want to find the 7th term, we're going to have 9 choose 6. And then as soon as you know that this is 6, this is going to be 9 minus 6. This is going to be r, which is 6. Our 8 value is our first one. Our b value is our second one. And if there's a negative sign, we put that negative sign with the b value as well. And then it's a matter of just calculation, so we won't waste our time. Again, good process is to do this calculation separate. When this whole thing is cubed, the 2 gets cubed, so you get 8. And this negative 3 goes to the power of 6, so it becomes 729. Then you can multiply all of your coefficients together and get a final answer. So there's 2 more Binomial theorem questions coming up on this page. We'll do the next one together as well, because this was another type of question that we had. Find the term with a y to the 12 in this expansion. So if we go to our formula, we notice that the only place, okay, if I go to my formula, and I'll write it out here at the bottom first before I show you what I have underneath, I would know that n is 9 because that comes from our exponent. I know my term 1 is a 3x, and this is 9 minus r. And I know that negative 4y squared is there, and then there's an r there. We don't know what r is. Some questions we're going to have to do a fair bit of math to figure out what r is. This is not one of them. We want y to the 12th. The only place that there is a y is here. Sometimes we're going to have ones where they say find y to the 12th, and there's a y in both this b spot and the a spot. Then it becomes a little bit more complicated. But in this case, there's only y in the one spot. So the only thing that's going to affect the y is this term right here. So what does r have to be in order to get a y to the 12th? R has to be 6. So from this one, you can just start your formula. You could put r in temporarily, and then you would find out that r has to be 6. And then from there, plug it in. It's term 7 if r is 6. Plug in all our values. And get our final answer. Now the third question, this one does involve both parts. Because the third question is asking to find the constant term, and that's going to
Sorry for the interruption. If we could please now have the grade 9 students with the last name beginning.
So what does a constant term mean? That means that there would be just a number. In other words, the variable, if it had an exponent, would have an exponent of 0, because then it would disappear. So we need all of our x's to disappear here in order to get that constant term. Now if we think about what we have, we would have 14, choose r, 3x squared to the 14 minus r, and negative 1 over 2x to the 5 to the r. So we're going to need to figure out what r value will do that. You don't have to write this one because it's the same thing with an n. So what we do is we temporarily ignore everything that would involve the numbers in front, because what we're really concerned about is getting x to the 0. So you notice I'm going from here, I'm going to use n instead of r, although if you use your imagination, you can think of that as an r poorly written. Okay? Notice that I'm going to ignore the 14 choose n out in front, because that's just going to be a number. I'm going to ignore the 3 in front of the x squared, because no matter what the power is, that'll just be the coefficient of that term. And I'm going to ignore the negative 1 and the 2. But because x to the 5th is in the denominator of my fraction, I'm going to still keep it there, because that's going to be important. So now if I just consider the x squared, here I'm going to get x squared to the 14 minus n. That's what's going to be in my numerator. On the bottom, I'm going to have x to the 5 to the power n, because this exponent n here would go to that entire fraction. And now I need to figure out a value of n so that everything cancels out. Now probably last year sometimes you may have used guess and check, because there's not that many to try to find it out. If you want to use your algebraic skills, you can use your exponent laws. Remember that an exponent to an exponent means multiply. So we have 28 minus 2n over x to the 5n. And another exponent law, when you're dividing powers with the same base, you just subtract the exponents. So I'm going to have 28 minus 2n minus 5n. And what I end up having is an expression where x to the power of 28 minus 7n is equal to x to the power of 0. Now, if you've got one power equals another power with the same base on both sides, it's obvious that the exponents then must also equal. So 28 minus 7n has to equal 0. And then you can solve for n to get n to be 4. All that work just to find out n was 4, to find out it was the fifth term that we're looking for. Now we can go plug in n equals 4 and actually find what the constant term is. And one nice thing about once you plug it in, you should have all of your x to the 20s, all of your x's, in this case x to the 20, they'll all cancel out. Then you know, yes, I did find the constant term. If something were to happen that they didn't cancel out, then you would know that you either made a mistake in your simplification or your n value was incorrect. All right, one for you to try this next one. The number of terms in this expansion, well, if it's to the power of 6, if your n value is 6, you'll always have one more as the total number of terms. One way that I remember that is I just take something simple. If it was squared, you know that you could expand that. You would have 3 terms. So you have one more than the exponent that you have. If it was x plus 2 cubed, you would have 4 terms. So because the power is 6, we're going to have 7 terms. Now find the term containing x to the 12. Again, we plug in a value here. I should have used r instead of n. Maybe that's just a bad r. And then work through ignoring the terms in front, just looking at the exponents, and you'd have an n equals 3. So then you could plug everything in and find your term to be negative 540 x to the 12. So you've got an expansion here, and you want to find the value of n. 2 different ways that you can see this value of n. You know from your formula it's n choose r, so the fact that it's 10 choose 4 tells you right there with the 10 that that would be n. The other thing is right here and here, these 2 numbers will always add up to 10. Or will all not add up to 10, but add up to whatever this number is. So that could be another way. If the number in front, they'd actually given you a number, right? 10 choose 4 is equal to something big. And that number was actually written there. You could figure it out from there. So write down the values of a and b in terms of p and or q. Well, a is equal to p and b is equal to 2q. And the 6th term in the expansion, you could start it like that and then simplify it from there. But we won't waste time simplifying it right now because you want to start question 6. So now we know it contains in the 6th term an x to the 16. You have to find the value of n. So what we have to start with, we plug everything into the formula that we know, except we don't know n.
Sorry for the interruption. If we could please now have our grade 9 students with the
So again, if you ignore the things that have numbers and just use your exponent rules, you know that the x has to have an exponent of 16 in the end. Solving for n then gives you n is 12. And it doesn't ask you to find the whole term, it just asks you to find the value of n, so then you're done. So sometimes the IB exam likes to take one topic, this is the binomial expansion, and combine it with another topic just to see if you're able to do work with it in a slightly different scenario. Now the other topic that question number 7 joins it with is just basic algebra. Notice that we have an expansion here, 3x squared plus k over x to the power 8, but there's an added x squared in front. Okay? Now, all that means is whatever term you get gets multiplied by x squared, and that in itself shouldn't be overwhelming, but sometimes putting two concepts together is just enough to make you go, I don't know what to do, and give up. So we want to make sure that we have a look at some of these and say to ourselves, how does that change things? We want a constant term now, and we're used to doing a constant term if this wasn't there, right? Then you're just looking for x to the 0, because you're looking for all the x's to cancel out. But now that there's this x squared here, what does that do? That means that what we wanted to find originally can't have an x to the 0, because if it gets multiplied by x squared, then you don't have a constant term anymore. Can you see that now this part in the brackets with the k would have to have an x? This part here would have to have an x to the negative 2. So that when you multiply that by an x squared, you still get your x to the 0. K is a number. Yeah. And we're trying to find the constant term. Yeah. So k is a value. Yeah, k doesn't include an x. So does that make sense that you're wanting to find now the expansion part to have an x to the minus 2? So when you multiply that by that x squared out in front, you get a constant term. So now we just need to solve for n using our exponent laws. And we get n equals 6. And then you can plug it in to find it. Should have an x squared out in front here, because we have an x squared out in front of the expansion anyways. Now in my math, I knew that the x's were going to all cancel out. And you can see, maybe see that, you can see that you're going to have an x to the 4 on the top here, an x to the 6 on the bottom, and then multiplied by another x squared. All of those x's will cancel out. So moving forward, I've just got the math with my numbers, because I know my x's cancel out. And now we have k to the 6, and we have to solve for k. And then right at the end, there's one last little thing to see if they can catch you on something. Because 6 is an even power, when you take the 6th root, just like when you take the square root or the 4th root or the 8th root, you have to remember that it could be positive or negative that would make that work. All right, last one. expand x minus 2 to the power 4 and simplify your result. So according to your formula sheet, you could plug that all in. Term 1, term 2, term 3, term 4, term 5. You could write that all down. And you could simplify each of those and you would get this. I'll remind you of another thing that you learned in previous years as well. Do you remember Pascal's triangle? So we've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and I'll stop there because that's the one that has 5 terms. And the 1, 4, 6, 4, 1, that's what these numbers are here in the combination part. And then we notice that we start with our first term to the power 4, and it goes down each time. So you'd have 4, then 3, then 2, then 1, then 0. And our second one, it starts with none of them, and then goes up 1 each time. So if you wanted to use Pascal's triangle, you could start with your 1, then you would know you would have x to the 4 and negative 2 to the 0, plus, then there's your 4, and you would have x to the 3 and negative 2 to the 1. Then you'd have your 6, x squared, negative 2 squared. Then you have another 4, x to the 1, negative 2 cubed. And finally, you have your last one, which would have x to the 0 and negative 2 to the 4. So that's using Pascal's triangle. But it's exactly, notice the formula, 4, 3, 2, 1, 0, has that in there as well. And so now that we've expanded it completely in part A, what do? We'll add some algebra to this. If you had a 3x plus 4 in front of that, all that means is you'd have a 3x plus 4 in front of that expanded form that you found. And you need to find the term containing an x to the 3 in this. So maybe you notice the only way I'm going to get an x to the 3 is if I take this 4 and multiply this by this negative 8x cubed. That will give me an x to the 3. The only other way I can get an x to the 3 is if I take this 3x and multiply it by that 24x squared. Putting those together, we'd have 72x cubed minus 32x cubed would give us 40x cubed in the end. You wouldn't need to expand the whole thing, but you could. If you really wanted to, you could expand the whole thing and then in the end just say it's 40x cubed. But if you can see from the expansion that those are the only ones that will give you an x cubed, it is a little bit faster.